Okie dokie, artichokes. Hey, welcome to our next chapter, which is going to be on what is called a polynomial. Okay, so today our lesson is going to focus on adding and subtracting polynomials. So let's jump right into it. All right, first of all, let's talk about some key terms we're going to focus on these next couple sections. So again, today we're going to talk about adding and subtracting polynomials. First of all, what the heck is a polynomial? Okay, now first of all, we're going to start off by looking at the most simplest case of what a polynomial is. Okay, and that is what's called a monomial. Okay, a monomial. Now, what does a monomial mean? If you break this word down, mono, what does that mean? That means one. So a monomial is a number or a variable or a combination of a number and a variable written together. Okay, so for example, a quick example of a monomial would be the number 1. Okay, that's a monomial. X, that's a monomial. I can look at the combination of a number and a variable like 2x. That's a monomial. Or maybe two variables combined, x squared. That's a monomial. What I always think about with monomials and other types of polynomials is the number of terms we have. So a monomial only has one term. Mono means one. One term, that would be a monomial. So we'll look at other polynomials that have then more than one term. Okay, so next thing we're going to look at is the degree of a monomial. Degree is going to represent what we talked about last chapter, which is exponents. So different types of polynomials we'll talk about within this chapter, they are separated basically by degree, by their exponent. Okay, so the exponent, or sorry, the degree of a monomial is basically the sum of all the exponents you have in that term. Okay, now when we look at the exponents specifically, we're going to talk about with the variables that we have. Okay, so if we look at the number 100, well, if we look at the number 100, is there a variable? No, there's not a variable. So really, what's the degree here? If we add up all the exponents, we don't have any exponents. So what's the sum of those exponents? In this case, it'd be 0. So this would be considered a 0-degree monomial. Okay, the second one, we're going to look at our exponents. We have the m and the n. We see that we have m to the second power, n to the second power. We add those together, our degree is going to be 4. So that would be a 4th-degree monomial. Okay, now notice here we're going to ignore the numbers. This really only deals with the variables. So we're going to ignore that number of 100 and ignore that number of 5. We'll talk about what that is a little bit later. Okay, next one we have 10x to the 3rd power. We just have x here. We have 1 power of 3, so that means this would be a 3rd-degree monomial. Okay, then the last one we have 4ab to the 3rd. All right, so we have a and b are two variables. You may see 3 here with the b. Okay, so we have a 3. Now what's the variable with a? We have a written by itself. So what would be that exponent? Well, that exponent would be 1. So if I add those together, this would be 4. So this would be also a 4-degree monomial, I'm sorry. Notice here that the second and the fourth one, we have the same degree, but we have different letters, different powers going on there. Okay, but we can have the same degree of that monomial. All right, let's talk about some other key terms here. So we talked about what a monomial is. What is a polynomial, which is our focus of this chapter? Okay, so if you break this down, what does poly mean? Well, poly means many. So this is many nomials. Okay, so what does that mean? Well, many means more than one. So we could have, a polynomial can be a monomial. So I can have, for example, x squared, one term by itself. That would be a polynomial. But I could also have multiple terms. Now, how do I combine terms? Is basically I'm going to add or subtract them. So I could have x plus 1 separated by addition, the sum of two monomials. Here's a monomial, here's another one. Add two monomials together. I have two monomials. That would be a polynomial, okay, which is many nomials, many monomials. I could also have 3x squared plus x plus 1. Heck, that would be a polynomial. That has 3 monomials all added together. So those are some examples of polynomials, more than one. Okay? All right, now when we get more than one monomial, we're also going to talk about what is the standard form of polynomial. So let's say if I take, for example, take these 3 monomials. Say x squared plus 1 plus x to the 3rd power. Take that, for example. Let's say I take these 3 monomials and add them together to form a polynomial. Okay, so when I properly write a polynomial, what I'm going to do is I'm going to write them in descending order. Meaning I'm going to look at these monomials, and to write it in standard form, I'm going to look at the degree. Okay, and I'm going to put them in the degree from descending order. Now, what does descending mean? That means it's going to decrease from left to right, meaning you're going to have the biggest number on the left, biggest degree on the left, and smallest degree on the right. So if I look at these three, which one has the largest degree? Well, I have my exponents. The degree of 2. This one, there is no exponent, so this would be 0. And there I have 3. So if I put these in descending order from left to right, I would have my exponent of 3. Add to that my exponent of 2. Add to that my exponent of 0. And that would be written in standard form. So again, notice the exponents are in descending order from greatest to least. Starting big, going small. Okay, now what about numbers? Notice here I'm focusing on variables and exponents, but I really neglected the numbers. So what happens if I get 100x squared? Why don't I really take into consideration 100? Because 100 is basically another term. It's another thing we're going to look at, and this is called the coefficient. Okay, the coefficient of a term. All right, so in this case, 100x squared, x would be our variable. The second power would be our degree. This whole thing right here represents a monomial, but the 100 represents the coefficient. It is the number in front of the variable. All right, and if I were to add multiple terms to this, so if I were to add, let's say, add x plus 1, kind of like the last example I had. So if I were to combine 3 monomials together, 100 being the first term I have here, this is also known as the leading coefficient. And these are just a bunch of vocabulary words that we're going to use throughout the chapter, so we've got to familiarize ourselves with them. Leading coefficient represents the first, one that's in front. Okay, and then lastly, kind of like a monomial, the degree of a polynomial is going to be represented by the greatest degree of its terms. So if I take a look at one example, take a look at the example we just had, 100x squared plus x plus 1. So if I look at the degree of a polynomial, I'm not going to do what I did in the last example for a monomial. I'm not going to add the exponents together. But the degree of this polynomial is going to be represented by the leading term. So what the heck is the leading term? That's going to be 100x squared. And if I look at that leading term, what's the degree of this term? Well, again, when we look at degree, we're just going to look at the variable and its exponent. So I see it has an exponent of 2. So that means this polynomial would be a second. That's a little sloppy. Let me erase that. This would be a degree of 2, or a second degree polynomial. It would be a degree of 2 because of that leading term. Okay, so just a couple key terms that we're going to look at throughout this chapter. All right, quick example here. We're going to look at taking this example. We're going to write it in first. Let's put it in standard form, identify the degree, and then what is the leading coefficient. So we got 3 things we're going to look at here. So again, first of all, what does standard form mean? Standard form says we're going to put it in descending order in terms of our exponents. So here I have an exponent, negative 4x. That's really an exponent of 1. Then I have 3x squared, minus 2, no exponent there, plus 4x to the third. So I look at here. This is going to be my first one, 4x to the third. That's my largest exponent. Then I look at the second largest, would be 3x squared minus 4x minus 2. Okay? So that would be written right here in standard form. Okay? Then, looking at standard form, what's the degree? Well, the degree is going to be represented by the largest exponent I have within these terms. So the largest exponent is going to be found in my leading term, 4x to the third. That means I'm going to have a degree of 3. Okay, this is my largest exponent. It would be a degree of 3. Next one, what is my leading coefficient? I'll write that as LC. Excuse me, my leading coefficient is going to be, again, the coefficient is the number in front of the variable. So if I look at the leading coefficient, leading right here is going to tell about what's the one in front. So the one in front is the 4x to the third. Its coefficient is 4. So this would be a leading coefficient of 4. So again, just familiarizing ourselves with these key terms. Okay, so we express polynomials in terms of being a combination of monomials. So what happens if we have more than one monomial? Well, here are the proper names we're going to fit to them. Okay, a monomial has one term. Remember how I said I express these in a number of terms? Monomials have one term, such as x. When I add another term to it, I have two terms. That's called a binomial. So this would be x plus 2, for example. Two terms, that's a binomial. Trinomial would be three terms. So let's say I go x squared plus x plus 2. Okay, that one, notice how I have three monomials added together. Three terms, trinomial. Tri means three, bi means two, mono means one. All right, so let's look at these examples, see if we can identify it. So what I want you to do right now, using these notes, I want you to pause, and I want you to tell me what is the degree and what is the name of this polynomial based off of the number of terms. So again, what is the name? So you're going to use these three names, and then what's the degree? So pause the video. Pause it. Okay, let's go ahead and check our work. Let's see what you got. So I look at the first one. I have two terms right away. That's a binomial. Okay, and the degree is looking at my leading term, 12x. What's the exponent? Not one written there. That means it's a 1, not a 0. Remember, anything to the 0 power would be a 1. So this one, x to the first power. So my degree is 1. Okay, tricky thing here with number 2. I'm going to tell you what some of you might have done. A lot of people see n to the third power. They're going to say trinomial because 3 means tri, right? Well, no. Remember, trinomial represents the number of terms. So I have one term here. That means this is a monomial. And the 3, the exponent here, represents the degree. So this would be a degree of 3. So exponent tells you the degree. Number of terms tells you the type of polynomial. So the last one here, this would not be a binomial because of the 2, but this would be a trinomial because we have 3 terms. But it would be a degree of 2 because my leading term has an exponent of 2. So that would be my degree. All right, hopefully you got those right. Okay, now what we're going to do is talk about just some basic arithmetic with polynomials. So how are we going to add and subtract polynomials together? So now that we understand what polynomials are in terms of the number of terms and their degree, now let's talk about adding them. So adding them is pretty simple. Basically, we're going to take one polynomial, multiple terms, and add them to another one. So what are we going to do when we have multiple terms and we add it to another thing that has multiple terms? All we're going to do is we are going to combine like terms and just basically simplify it. So to remember, what is a like term? Well, like terms, remember, they have the same variables. So that means x and x, y and y, z and z, m and m, w and w, as well as the same exponent. So x squared and x squared, x and x to the third and x to the third. So in order to combine them, you'd have the same variable, same exponent. So let's look at the first example here. 5x to the third minus 3x plus 2. Add to that 3x to the third plus 2x squared plus 5x. So what I'm going to do is basically look at like terms. Okay, this is one polynomial. We have a trinomial. Added to it another trinomial. So I'm going to combine the like terms. So where do we have like terms? Well, I see x to the third, x to the third. So I'm going to combine these two together. How do I combine them? Well, I'm just going to add the numbers together. What's 5 plus 3? That's 8x to the third. All right, moving on. I have next one. Negative 3x. So notice I just have the x. Let's look over here. I have a 5x over there. So I'm going to combine these terms. So let's add them. Negative 3 plus 5. What is that? That's not 8, but that is going to be 2x. And then lastly, okay, let's see. I have here 2. That's a number. Do I have 2 written over here on the other trinomial? No, I don't have 2 written at all. So that one I'm just going to add by itself. I can't combine it with anything. Last one, I have 2x squared on this one. Don't combine it with anything. There's no x squared anywhere else. I'm going to add the 2x squared. So how many think you're done? Hopefully none of you, because this is written in standard form. Remember, standard form, we want descending order of our exponents. So no, this is not. We have to rework a little bit. 8x to the third is my largest exponent with the power of 3. Then I see 2x squared. That's going to come next. Then 2x. And then 2. So last step here, make sure we write this in. Put a little star here, maybe make a note of this. Standard form, y'all. Okay, make sure it's written in standard form. So all I did there was I added these two trinomials together to get this type of polynomial. With this one has 4. We haven't talked about that, but there's 4 terms there. So that would be a different type of polynomial. Okay, rubbing a little extra sass in it, let's talk about how do we subtract polynomials together. Okay, subtracting polynomials is a little different than adding. Okay, when we subtract, you can think of it when I say, let's give you a simple case like 4 minus 2. Well, 4 minus 2 is really the same thing as saying 4 plus negative 2. Basically, you're adding the negative of whatever that second term is. So we're going to do the same thing here. When I subtract polynomials, the biggest mistake students will make is basically to take minus negative 4 and say, okay, hey, that's a positive, but then forget about the rest of the term. When you look at this, what you have to think about is that this is really 6x to the 5th power minus 3x plus a negative and a negative what? A negative 1 of this entire term. So what do I have to do if I have negative 1 times that entire polynomial? Not term, I said term on accident, polynomial. What do I have to do? I must distribute the negative 1 first. So you have to think of subtraction as adding a negative. So when I do that, here's what's going to happen. I have 6x to the 5th minus 3x. When I distribute the negative 1, negative 1 times negative 4, that's going to give me positive 4x to the 5th. Then I have negative 1 times 2x, that's going to give me minus 2x. Negative 1 times negative 5 is going to be plus 5. So notice what happened and what really happened. What's a shortcut way to think about it? Notice that all the signs of that second polynomial changed. I had negative 4 turned to positive, positive turned to negative, negative turned to positive. So that's basically what happens with subtraction. It's a shortcut way. Now what do I do next? Well, I'm now adding everything, so let's do what we did before in the last example. It's combined like terms. 6x to the 5th plus 4x to the 5th, that's 10x to the 5th. Negative 3x, do I have any other x's? Yeah, I have negative 2x. What's negative 3 plus negative 2? It's not negative 1, it's not 1, but it's negative 5x. Okay, then I have, lastly, I've gotten rid of really, boom, got those, got those, got those. I have the plus 5. All right, I've combined like terms. And lastly, is it written in standard form? You bet it is. It's in descending order, so that's our answer. So again, key thing here, think about just basic numbers. When you subtract numbers, it's like adding a negative. It's the same idea with polynomials, ya dingus. All right, here we go. Let's try ourselves a combination of addition and subtraction. So we have a trinomial here, subtracted by a binomial, adding to it a trinomial. So how the heck do we do this? Let's just take a number example, 2 plus 1 plus 3. I'll make it similar. Let's say 2 minus 1 plus 3. Skip that one. What do I do when I do this? Well, I got to start with 2 of them first. Start with 2 minus 1. That's 1. Then add to it 3. That's 4. Right? So I do 2 at a time. So when I do this first, let's start with the first 2. So I have 5x to the 3rd minus 2x plus 1 minus the binomial of 2x squared plus 4x. So what do I do here again? Just like the last example, 5x to the 3rd minus 2x plus 1. I'm going to add to it the negative 1 of 2x squared plus 4x. I'm just going to ignore this last term for now. I'll bring it down in the end. So when I do this, I'm going to distribute that negative 1. I have 5x to the 3rd minus 2x plus 1 minus 2x squared, distributing the negative 1, minus 4x. Okay? Then I'm going to bring down plus x to the 3rd plus 5x squared minus 8x. Notice here I dropped the parentheses. When I'm adding, it doesn't really matter. Remember, addition's not going to change anything. Only subtraction is. So now what I'm going to do is combine the like terms. So let's look at 5x to the 3rd. Do I have any x to the 3rds? Ooh, I got one right here. So 5x to the 3rd plus x to the 3rd, 6x to the 3rd. Okay, start the next one. Negative 2x. Do I have any other x's? I have negative 4x. Oh, and negative 8x. So what's negative 2 minus 4 minus 8? Okay, negative 2 and negative 4 is negative 6. Subtract 8 from that, you're going to get negative 14x. Okay, let's just continue on. So I got rid of these. I got rid of the x's. Okay, Let's then combine the 1. I have plus 1. Do I have any other numbers by itself? No, so I have the plus 1, so that's gone. Then negative 2x, or 2x to the second power and 5x to the second power. Add those together. What's negative 2 plus 5? That is plus 3x to the second power. I've now combined all the like terms. Am I done? No, let's write it in standard form. So I have 6x to the third. That's my largest degree. Plus 3x squared, second largest, minus 14x, plus 1. All right. We've now entered the cool guy zone. We finished that one. Okay, so we did subtraction and addition all in one. All right, my little younglings, here's what I want you to do. Try these two. So I want you to pause the video right now and attempt number 1 and number 2. You have an addition and subtraction. So give her a pause. Go. All right, let's take a look at what we have. So the number 1, simple addition. Okay, all we do with addition is combine like terms. So I have m to the second power, 4 and minus 3. That's going to give me 1. Negative m, 10n. 10 minus 1 is 9. And 2 and 7, 2 plus 7 is 9. So simply, this one easy. 1m squared plus 9m plus 9. Second one required a little extra work. Okay, I have this binomial subtracting this, oh boy, 4 terms here. So what do I do when I subtract? I add the negative of the second polynomial. So what does that mean I have to do? That means, folks, that I must distribute this negative 1 to the second polynomial. And that's the part that most people forget. Doing that again, it's just going to change the sign. I have minus 2n third plus n squared minus n minus 12. Okay, then I combine like terms. So I started with the minus n squared. Minus n squared and n squared here give me 0n squared. Okay, talk about that in a second. Then I have the 2n minus n. That gives me 1n. And then I have minus 2n to the third. Doesn't combine with anything, so that's by itself. And then minus 12 by itself as well. Now notice here I crossed out 0n to the second. Why don't I keep it? Well, 0. Anything times 0, doesn't matter what that is, anything times 0 is going to drop out. So I don't need to write anything 0. I wouldn't write plus 0 at the end. I'm going to let it go. I'm going to drop it out. So then I wrote it in standard form. This is what I am left with after I drop that 0. And therefore, this is my final answer, negative 2n to the third plus n minus 12. Okay? And again, what would be this degree? I forgot already. Oh, yeah. This degree would be a third degree trinomial in this case. All right, so that's adding and subtracting polynomials. We'll see you guys in class. Take her easy. I'll catch you on the flip side.
It's Brule's Rules with Channel 5's Dr. Steve Brule.
Hey, I'm Dr. Steve Brule with some of the Brule's Rules. Does your milk taste sour when you take a sip of it? Just check the expiration date, dummy. For your health.